Today we're going to be talking about law of sines, law of cosines, and the area of a triangle. First, let's define what an oblique triangle is. We have used trigonometric ratios to solve right triangles. Law of sines and law of cosines enable us to solve oblique triangles, which are triangles that are not right triangles, given at least 3 of the measurements as long as at least one of them is a side. Keep in mind that given the measurements of the 3 angles, we can come up with different triangles which are similar but not congruent. We can solve a triangle by knowing the following things. And remember, solving a triangle means finding all of the angles and all of the side lengths. So we can do that if we're given A, one side and 2 angles. We're either going to call this angle side angle or side angle angle. Case B is if we are given 2 sides and an opposite angle. We call this side-side angle, and this is a special case that may lead to no triangle, 1 triangle, or 2 triangles. Case C, 2 sides and the angle in between them, which is called side angle side. And then the last case, case D, is if we are given all 3 side lengths, which we call side side side. Let's draw these 5 situations with a dashed line for the unspecified side or angle. So the first case that we had was angle side angle, and that's going to look like this. So we know angle, side, angle, and then we don't know this angle or the other 2 dashed sides. Then we have side, angle, angle. That's going to look like this, where we know one side, we know angle, and then we know this angle. The third case was side-side angle, and that looks like this. Now, this is kind of the special case because we can actually have it where sometimes there's what we call like the ambiguous case, and then the triangle actually looks like that. And we will encounter some examples of this in just a moment. So the next one is side angle side. So that's what that would look like. And then the last one would be side, 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 where we know all of the side lengths. And then we'd have to figure out all of the angles. For the first 2 cases, A and B, we will be using the law of sines. And then the last 2 cases, C and D, we will be using the law of cosines. So let's go ahead and jump into learning about each of those things. The law of sines says for a given triangle, the following ratios hold true. Sine of A over A is equal to sine of B over B, and that's also equal to sine of C over C. Now, in this notation, note that capital letters denote angles, and lowercase denote side lengths. Okay, and it's also important to keep in mind that if you were to add up all the angles of a triangle, they should add up to 180 degrees. Let's jump into example 1. It says solve triangle ABC, where Angle A is equal to 32 degrees, angle B is equal to 81.8 degrees, and side length A is equal to 42.9 units. So it's nice that we have a triangle already drawn for us, so I'm going to fill this in and say that this is 32 degrees, this is 81.8 degrees, and then side length A is equal to 42.9. And now we need to use this information to solve for the rest of the side lengths and the rest of the angles. Now, we're only missing one angle, and that's angle C, and we should be able to utilize the fact that the sum of the angles should add up to 180 degrees. So if I add 81.8 to 32, that gives me 113.8 degrees. And then I can subtract that from 180 degrees. So that is going to be 66.2 degrees. So I'm going to fill that in here on my triangle. And now we can go ahead and solve for the side lengths of lowercase b and lowercase c. So I know that sine of, if I'm using the law of sines formula that we have up above, I know that sine of 42.9 degrees over, oops, that's the side length. I meant to write sine of 32 degrees over 42.9 is equal to sine of 81.8 degrees over, I'm going to put lowercase b since we don't know what the length of b is. And now if I cross multiply, I will get that b times sine of 32 degrees is equal to 42.9 times sine of 81.8 degrees. And now I can divide both sides by sine of 32 degrees. And this is where I am wanting to use a calculator. So I want to make sure that my calculator is in degrees. And now I can throw that into my calculator. So I'm going to do 42.9 times sine of 81.8. And then I want to divide that by sine of 32 degrees. So that gives me 80.1. I'm just going to round it to one decimal place since the other angles and side lengths are rounded to one decimal place. So this is 80.1. Maybe I'll put an equal sign. Okay, so we know that b is 80.1, and now the only value that we are missing is lowercase c. So I'm going to erase this stuff to make some room, and I'm going to say that sine of 32 degrees over 42.9 is equal to sine of 66.2 degrees over lowercase c. And then if I cross multiply again like we just did, we'd get c times sine of 32 degrees is equal to 42.9 times sine of 66.2 degrees. And then if I divide both sides by sine of 32 degrees, we get c is equal to 42.9 times sine of 66.2 degrees divided by sine of 32 degrees. And I'm going to throw that into my calculator now. So I have 42.9 times sine of 66.2. And then I'm going to divide that by sine of 32 degrees. And that tells me that lowercase c is equal to 74.1 units. So I'm going to put 74.1. Now, it's nice that I have this triangle here, and so I have written out all the angle values and all of the side lengths. So those are my final answer, and I have solved the triangle ABC.